Good evening, everyone. So we will start the session within 1 or 2 minutes. We are expecting some more students to attend this session.
Chandramouli.
Yeah, I'm ready. If you say I can start, no issues.
Okay. So good evening, everyone. So first of all, we are happy to organize this workshop organized by SAB IIT Guwahati. It was my pleasure to welcome Dr. P. Murugan to today's SPSS workshop. So Dr. Murugan is an assistant professor at the School of Management Studies at University of Hyderabad. He holds a PhD from Anna University, Chennai, and he has worked with the prestigious institutions like IIM Shillong and IIT Trichy. He has been recognized with the Chancellor Award from the University of Hyderabad for his excellence in teaching and research. With expertise in multivariate data analysis, moderation analysis, and structure equation modeling, and more, Dr. Murugan has published in top journals and served as a senior editor for the Career Development International Journal. He has also conducted over 250 workshops across leading universities in India, and we are excited to learn from his extensive experience today. So please join me in welcoming Dr. Murugan.
Thank
So
you
all
so
the class is
much,
yours, sir.
Mr. Mike. Yeah. Sorry?
Now the class is yours, sir. You can take the
Yeah.
class.
Fine. Thank you, Mr. Mike, and thanks to Professor Cyril sir for the invitation. We have some long-term association, I think at least for the last 2 to 3 years. Thank you so much, sir, for the invitation. I'll try to do the justice, but later you have to ask your people so whether they got something from this
Yeah, I'll
particular
get
lecture.
back to you.
Yeah,
Yeah.
fine, sir. So let me start the session. I'll share my screen. So I have two different monitors. If the people are really comfortable in terms of showing their face, you're most welcome to unmute to your video so that I can also see the people.
Yeah, I will also make a small request to all the students. Whoever, like it's possible, please switch on your camera also. Like that would be a good aspect to the person who is taking the class in terms of feedback.
Yeah, actually, sir, in online courses, you know better than me. Without seeing the people, so sometimes I feel like whether I'm doing the session for the system or for the
Correct.
audience. Fine. So I hope you are able to see the screen. Let me swap the screen instead of duplicating the, yeah. So I hope now you are able to see everything. Also hear me properly. Yeah, I just dragged the Microsoft team into the next screen. Yeah, I could see Rahul Kumar very well. Thank you, Rahul. And another Rahul Kumar. Yeah, same Rahul Kumar. Thank you so much. Fine. So, see, if you look at this content, you have an exclusive textbook on structural equation modeling. And if you look at some of the Western University curriculum, there's a separate course, exclusive course is also being offered by the faculty members in terms of teaching the subject. And there are two perspectives are available in terms of understanding this particular content from applied orientation as well as application orientation. So, for example, in economics domain also, you do have something called simultaneous equation modeling. that is also something similar to SEM, but not exactly similar to SEM. So that is somewhat different from the SEM which we use in behavioral science research. So as far as this session is concerned, what I'm planning to do is for the first 1.5 hour or 2 hours, I'll give you some rough idea and overview about understanding structural equation modeling, confirmatory factor analysis, and why we use structural equation modeling, why we use um, basically confirmatory factor analysis. And in most of the cases, especially in experiments and survey research, even in longitudinal designs, we use them widely. Even in the context of multi-level modeling, we also apply something called multi-level structural equation modeling. So if you really look at this term, this itself is a ocean. So there are two exclusive journals also available. There is a journal named Structural Equation Modeling that is coming from Science Direct, and there is another journal called Structural Equation Modeling, a multidisciplinary journal coming from Taylor and Francis Publishing House. So, which means that I mean this topic is itself is a kind of big version, something similar to multivariate data analysis. So in 2018-19 and all, I have offered 5 continuous days to teach structural equation modeling. But especially after COVID, I kind of condensed everything into maybe for 3 hours or 1.5 hour, in some cases 1 day, in some cases half a day, in some cases 2 days and so on. That is how I'm trying to explain everything. And if you want to learn something more about this, my roadmap for you is you can start your reading from the Tolman et al. Paper. The next you start reading multivariate data analysis by Hairbook. You can read the first 2 chapters. Then there's a separate book called Structural Equation Modeling Using Amos by Barbara Bainey. So these are the few references you can use in terms of understanding this particular technique. If those references are not available in your library, feel free to recommend it to your librarian so that they'll get you those books. And if you need mathematical orientation with respect to understanding SEM, a lot of online resources are available. Otherwise, you can also refer. There is a book called Structural Equation Modeling by David Kaplan. So that particular book will give you mathematical orientation in terms of understanding SEM. And Amos is widely used software in India, but I mean, at the cross-section level, yes, you can make use of Amos. But when you have a multi-level data, I don't think so Amos can perform the job. So for which again the recommendation is you try to make use of our platform, or you can also use M plus. M plus is again another commercial software, something similar to Amos. M plus can do whole lot of things which Amos can't do. For example, when you have a moderator which is latent constraint in nature, and when you want to test moderated mediation, then M plus will do the job even at the same level. You need not to use even process macro also. So a lot of complex things can be done with the help of M plus. Now, Bayesian estimation is the I mean, consider as next big thing. So if when you want to apply Bayesian estimation, so again, you can also make use of M plus software. So a lot of benefits are available in M plus. I'm not marketing or promoting anything related to M plus, but it has a lot of capability. So at your level, since you're all coming from IIT background, so my kind advice is try to make use of some of the open source platform like our platform. So I'm also comfortable in terms of delivering the same thing using our package called Lavan package. So with the help of that, you can do SEM, CFA, even if one can run multi-level SEM, everything one can do with the help of Lavan package. That is very much possible. But since the request came to me to use Amos software, so as part of this session, I'm going to use Amos only. Fine. So if you need more details about myself, you can visit my personal site. So especially if you go to resources page, so I've given a whole lot of references which might be useful for the OB, HR, marketing scholars, even for Journal of behavioral finance scholars, as well as whoever is trying to do some kind of behavioral science research. For those people, definitely those references will be useful. So for more details, you can visit my page and look at the resources page. So now let me get into the session. If you talk about some history on SEM, there's a person called Civil Wright. He's a genetist engineer. Basically, he's a genetist. So he tried to model some of the things related to his research work. And again, if you look at the literature prior to 1918 or 1920, not much has been done with respect to simultaneously analyzing different sort of relationship that is available in the literature. I mean, that is available in your theoretical model. So he found a way to almost analyze as well as quantify all sort of relationship that is there in your theoretical simultaneously, and then he has given a name called path analysis. So path analysis is nothing but it's a simple extension to your multiple linear regression model. So from there only almost we got this terminology called structural equation modeling. So in 1960s, the person named Joe Skagg, one was developed the software called Literal. Literal meaning is linear structural relation. So that is one of the, again, very famous software in the literature. So he brought measurement model and then integrated with the theoretical model. And then finally, he has given a new label called structural equation modeling. This is a small history to understand structural equation modeling development in the history. And in most of the research work, what we are trying to do is one side we try to develop the theory, another side we try to test the theory. So theory development is happening with the help of different approaches. One can also use inductive approach, one can also use deductive approach. In most of the empirical research work, quite often we use deductive logic in terms of developing our theoretical model or developing our theory. And we also try to test the same theory with the help of some empirical data points. So when you want to test your theory, one of the preferred approach in the past literature is structural equation modeling. Even now, there are papers getting published in the literature using structural equation modeling, even at the level of JAB, that is Journal of Applied Psychology, Academic Management Journal, and so on. But if you look at Journal of Marketing, hardly you see any of the papers which has used SEM, because now their focus is mostly towards field experiments, using secondary data or using live stream data. So that's the trend now that is existing in the literature, especially with respect to some of the top marketing journals are concerned. And if you look at JCR, Journal of Consumer Research, they do a whole lot of experiments, and with the help of the experiments, they try to prove something. And to handle most of the experimental data, you need not to use SEM. But again, to handle experimental data, there are some SEM-based approaches also available in the literature. So one can also make use of SEM or maybe simple regression-based approaches in terms of testing their hypothesis. And if you look at this tree sort of diagram, so here I'm trying to give you the explanation in terms of understanding the way in which how methodologists have developed this particular approach called structural equation modeling. So you know the concept of bivariate correlation, right? So the simple extension to bivariate correlation is nothing but your factor analysis as well as your simple regression. And then the simple extension to your simple regression is referred as multiple regression. And then the integrated version of your path analysis as well as your confirmatory factor analysis is nothing but structural equation modeling. So mathematically, if you ask me a simple question, I mean analytically, so what is SEM? I would say that MLRM plus your factor analysis is nothing but SEM. So SEM is having the capability of performing whatever we do in the case of regression as well as whatever we do in the case of factor analysis. So a bit of introduction to understanding factor analysis and regression. So can anyone give some explanation to understand why we use factor analysis? What is factor analysis? And when we apply multiple regression, anything from the participant side? Are you comfortable in factor analysis, principal component analysis, and then multiple regression? Are you comfortable? If so, can you give me some explanation? Anything from the participant side? Sorry? Yeah, can you give some explanation to understand what is factor analysis and what is multiple regression? Can anyone? So any research scholar in here?
Good evening, sir.
Hello, ma'am. Good evening. Yeah.
Hi, I'm Drishti. I do not understand the nuances of factor analysis much, but when it comes to regression, regression is basically when we try to see that how much of the percentage change in the independent variable is leading to a change in the dependent variable. So what is the strength of the relationship? And multiple regression, correct me if I'm wrong, multiple regression is used when there are more than two dependent variables. So yeah. So it again, if that is hierarchical regression, I'm not sure, but almost the papers that I have gone through in which they have done some kind of regression analysis, at every step they introduce one or two control variables in order to assess whether those variables have any impact or not on the dependent variables. If
I
they
think
don't
you're
do it
talking about hierarchical regression. Fine.
Yes, okay, so that will be hierarchical. Okay.
Yeah.
So then I do
both
not
are
have.
same only. Both are same only. Multiple regression, hierarchical regression, both are same only, but it's a different approach basically. Yeah, you are right. So in regression, what we try to do is we have set of independent variables. We are trying to predict our dependent variable. So in research parlance, what we are trying to understand is whether these factors are having some relationship with our dependent variable. That is what we are trying to explore in the case of regression. And in the case of regression, when you really look at any of the regression applications, we often deal with only one dependent variable and we might be having multiple set of independent variables. But practically, whenever we are trying to test our theory, it's not that we are going to handle or deal with only one DV and then set of IVs. Sometimes that DV may also have some effect on some other outcomes. So when you have those sort of complex models in in your theoretical model, then how are you going to test all those relationships? Okay. So that one can think of applying path analysis as well as SEM in terms of simultaneously estimating all those equations. So now before I get into SEM and path analysis, try to understand factor analysis. So in simple sense, factor analysis is a interdependence technique. So I can classify the entire multivariate data analysis techniques into two parts. One is dependence techniques and then another one is interdependence techniques. So in the case of in machine learning parlance, they use the term called supervised learning method and then unsupervised learning method, right? So supervised learning is nothing but dependence techniques. Unsupervised learning method is nothing but interdependence techniques. In ML literature also, you do have something called semi-supervised machine learning approaches. So I'm not getting into that part. So in interdependence techniques, you don't see the concept of IV and DV sort of relationship. Whereas in the case of dependence approaches, we do have the concept of set of IVs leading to set of DVs and so on. So those sort of relationship will be there in the case of dependence techniques are concerned. So as far as dependence techniques are concerned, we have concepts like multiple regression, conjoint analysis, canonical correlation, logistic regression, discriminant analysis, Tobit model, Probit model, path analysis. All of these, MANOVA, all of these things are coming under dependence umbrella. So when you talk about interdependence techniques, you have techniques like factor analysis, principal component analysis, cluster analysis, multidimensional scaling. Then you have techniques like latent profile analysis. So all of these things are coming under interdependence umbrella. So when you talk about factor analysis application, when we use factor analysis is, for example, you are doing a scale development process. And as part of the scale development process in the initial round, let us assume that you have developed, let us say some 30, 40 items. Now you went to the field and you got some numerical information from your respondents. And now what you are supposed to do is you need to identify the underlying dimension or underlying pattern that exists among your items. So when you are trying to develop a multidimensional scale, what will happen is, so whenever certain items are formed under certain factor, so basically that factor can be labeled as that particular dimension. Able to understand? So that is how we apply factor analysis in terms of understanding the underlying dimension that exists among our variables. So basically, sometimes it is also referred as data reduction technique or dimension reduction technique. This is all the explanation I used to give in terms of understanding factor analysis. Of course, as part of this session, I'm not going to cover anything on factor analysis. So when you look at the factor analysis application, especially in scale development process, we left and right use factor analysis. And even in if you're using standard scales in your research, and if the construct is multidimensional in nature, and when you want to understand the dimensions that is coming out of your data set, so again you can also employ factor analysis. Then after that you can get some conclusion. Okay, these are the items that is being loaded on this particular dimension, and these are the items that is being loaded on this particular construct, and so on. That is how you can understand after applying this factor analysis. And when you talk about multiple regression, so basically to understand the theoretical relationship among the constructs, we employ multiple regression. So the extended version of multiple regression is nothing but path analysis. Extended version of factor analysis is nothing but confirmatory factor analysis. The integrated version of your path confirmatory factor analysis is nothing but your structural equation modeling. So logically, when you ask me a question, what is SEM? SEM is nothing but the integrated version of your path analysis and confirmatory factor analysis. That is how you can understand. So let me show you a slide where I kept a diagram to distinguish your MLRM from SM and so on. So if you look at this left-hand side panel, so this model is nothing but multiple linear regression model, where you have set of x's. Those x's are related to single y. This y is nothing but your dependent variable. Okay. You may be dealing with more than 3 x's also, that's fine. And whenever you are trying to apply MLRM, that is multiple linear regression model in your research work, make sure that you have continuous or metric data points for almost all of the variables. Especially for y, you must have metric data. Otherwise, you can't implement multiple linear regression. Rather, you have to implement logistic regression or multinomial logistic regression. The extended version of MLRM is nothing but path analysis. For example, in MLRM, if this X1 is measured using 3 items, means what we do is simply we take the average of these 3 items, or we take the summated scores of this 3 item, and then we will have a single column of information to represent this X1. Similarly, when you look at path analysis, you have set of IVs that is leading to set of outcomes. But if you look at this particular portion of this path model, there's nothing but your MLRM model only. But if you look at this particular connection, so intention is also related to behavior. And when you're trying to simultaneously quantify everything in one go, this becomes your SIM model or path model. Able to understand? So for example, here intention is the dependent variable, attitude, subjective norm, PBC are considered as the independent variable. So all of these 3 independent variables are related to intention, which in turn that is related to behavior. Now, when you are trying to test this entire model, in one go, okay, in one go, basically that particular model is referred as path analysis or SIM model. Then what's the difference between path and SIM model? So the core difference between path and SIM model is, for example, this attitude might have been measured using set of items. But in the path analysis, I'm making an assumption saying that my measurement is free from error. And I'm just taking the average scores of entire set of items used to measure attitude, and then I'm giving that as an input in my data, that as an input in my model. Whereas in the same case, I'm also trying to keep all the items that is being used in terms of measuring this attitude. Able to understand? So along with the items, along with the theoretical relationship, I'm trying to quantify all sort of relationship that exist in the theoretical model. For example, if you look at the same model, so I'm trying to test the theoretical relationship between verbal IQ and performance IQ. Also, this verbal IQ is measured using set of items. This performance IQ is also measured using set of items. So basically here I'm trying to test the theoretical relationship along with the measured items. So when you keep all of these measured items in your theoretical model, I mean, you will be able to estimate, you will be able to estimate your error values also. You will be able to estimate your error terms also. Okay. So one of the key advantage of using SEM is we have the provision of taking into account of error part while estimating our theoretical relationship among the constructs. That is the beauty of using SEM. If you look at MLRM, there we are not explicitly taking into account of error, whereas we assume that our measurement is free from error. Simply we are trying to predict our Y with the help of set of X's. That is what we are trying to do in the case of MLRM. Whereas in the case of SEM, what is happening is simultaneously we are keeping all the measurement items as well as we are trying to estimate the theoretical relationship among the constructs or between constructs along with the items as well as item errors. So that's the beauty of using SEM. And if you look at CFA, in CFA, what we try to do is we are trying to validate our measurement model. What do you mean by practically validating the CFA model? For example, you are going to a tailor shop. You are giving some dress material to your tailor, and tailor is also making some measurement. And after few days, he or she is also delivering the final product. If the dress is exactly fitting with your body portion means the measurement is right. If the dress is the stitched material, I mean dress is not exactly fitting with your body portion means something went wrong with respect to measurement or the way in which how the tailor did the job. Are you getting my point? Suppose if there is an issue of measurement, final output will be questionable, right? Same logic is applicable in research also. So in CFA, what we are trying to verify is we are trying to validate our measurement model. So what do you mean by validating the measurement model? So at the theoretical level, we have something to say about our construct. At the empirical level, we have quantified our construct with the help of set of items. Now we are trying to check, are there any differences that exist between what exists at the theoretical level and then what we have quantified at the empirical level. So this difference is nothing but validity, and we are trying to establish different kinds of reliability and validity by running CFA model. So in CFA analysis, we are not trying to test the theoretical relationship between two constructs. What we try to do is we try to validate our measurement model. We try to validate our measurement model. Any questions from the participant side? Able to understand the differences between multiple linear regression model and then path analysis or path model and then SEM model, CFA model. Any questions? Any questions from the participant side? No questions? I think the participants are highly obedient participants. They're not asking any questions. Sorry, something happened, so it got disconnected. Yeah, I hope now you are able to see the screen, right? Yeah, any questions from this slide? If there are no questions, shall I proceed further? Okay, just small feedback is required from your end. Whether you are able to follow me properly, whether this flow is fine, or am I going really fast or really slow? Whether you are able to cope up with the flow. Can I get some feedback? It's fine, right? Yeah, fine. Okay, no issues. Okay, now try to understand some of the terminologies used in the literature. So the first terminology which I'm introducing here is latent construct. So what do you mean by latent construct? So latent construct is, okay, before that you try to understand the difference between construct and variable. Any idea from your side? What do you mean by construct or concept and variable? Any idea? Any idea? Can somebody respond? If you don't know, at least you say no. Any idea?
No, sir, actually. We don't know.
Fine. See, if anything can be directly quantifiable means that is referred as variable. Okay. If anything is indirectly quantified means it's a constructor concept. So in any social science research or behavioral science research,
Hi everyone, please do not panic. The internet connectivity from instructors end is like bit unstable. So please wait for the next 5 minutes. It will get resolved. Thank you.
Hi everyone, actually we have a break for 10 minutes. So see you all at 6:15. Thank you.
No, really sorry for the network issue. So I think in the ground floor they did some repairing work. So because of that reason, I didn't get the internet. So I'm sitting at my office only. Can
It's
you
okay,
hear
sir.
me? Yeah, fine.
Yes, sir, you are audible, sir.
So if everyone is available, shall I start?
Yes, sir.
Yes, sir.
Yes, sir, you can
Fine.
start.
So I just start while explaining what is latent construct. So see, if you really look at the literature, we have a lot of differences that exist in terms of distinguishing construct from concept as well as construct and concept from variables. But as far as this session is concerned, you consider that construct and concepts are same. And we do use a different terminology in same literature called latent construct. So whenever you see latent construct is actually referring some entity which is not directly captured by the researcher. So what we do is indirectly we try to capture those entities with the help of proxy items. For example, if somebody is asking me a question, how many of them are attending this session? So I would say that by looking at the people number, so including myself, 32 of them are attending this session. So this is directly quantifiable. If somebody is asking me a question of what is the gender of Ashutosh, simply I can say that he is a male. So I can observe directly, I can observe it, I can easily quantify it. For example, height, one can directly measure it. Weight, one can easily measure it. For example, your glucose level, using some devices, some equipments, you can easily measure it. But if someone is asking me a question, did I mean whether Ashutosh satisfied with my class? How do I measure it? So I need set of proxy items to quantify Ashutosh satisfaction level. Now able to understand? So in most of the behavioral science research, especially in OBHR marketing, wherever we are trying to capture the behavioral aspect of the subjects, so we use latent construct and we also use standard scales or standard items to measure everything. This is how we quantify everything. So that is nothing but latent construct. Any questions? And the items or questions or statements used in your questionnaire, right? So in same language, those items, question statements are sometimes referred as observable variables or observed variables or manifest variables. These are the two other terminologies we use to refer statements, questions, or items that is there in the questionnaire. Clear? Then the next one is manifest or observed variable. Already we had some discussion about this. Then you have something called exogenous variable and then endogenous variable. What do you mean by exogenous and endogenous? So for example, if you look at this particular theoretical model, here attitude, subjective norm, PBC are referred as exogenous construct. And then this intention, behavior considered as endogenous construct. So in simple sense, exogenous meaning is whose cause is outside of the model. Endogenous means whose cause is within the model. Because to define intention and behavior, all the causes are coming from these three variables as well as this one. But whereas for defining attitude and subjective norm and PPC, so we don't know the cause because we have not measured it, we have not accounted all those causes. So whose cause is usually outside of the model. So in simple sense, exogenous means independent variable, endogenous means dependent variable, or criterion variable or outcome variable. Exogenous means predictor variable or antecedent and so on. But in SIM, there is a possibility that a construct or variable may act as a exogenous as well as endogenous. If you look at this path model, attitude, subjective norm, PBC are referred as exogenous for intention, and the intention is exogenous for behavior. But at the same time, this intention is also endogenous for this attitude, subjective norm, and PPC. So intention is playing a dual role, exogenous for behavior, endogenous for attitude, subjective norm, and PPC. So what I'm trying to introduce here is in any theoretical model, you might be having pure exogenous constructs and pure endogenous construct. That is also possible. Now try to understand what is SEM, before that, I hope you know the meaning of measurement error, residuals and controls. I'm not giving any explanation here. In simple sense, measurement error is nothing but, according to classical test theory, any observed score will contain some proportion of true score plus error. That error can be classified into two parts. One is coming from the sampling side, another one is coming from the respondent side. The respondent sources error can be further classified into two types. One is, administrator error, or maybe systematic error. So systematic error is again classified into two parts. One is coming from the respondent side, and then coming from the administrator side. So like that, there are different types of errors are available. If you need more details about understanding error, measurement error alone, there's a book called Measurement Error and Research Design by Madhu Vishwanathan. So Madhu Vishwanathan is from University of Illinois. You refer that book. If you don't have this book at your library, strongly you recommend them to procure this book. Find one of the fantastic book to understand different types of error. So measurement error is, technically speaking, nothing but it's a artificial variations or variance that is coming from your data because of some biasness. Suppose if you are not in a good mood to provide responses for the questionnaire, obviously you give some random responses. So that is nothing but biasness. That constitutes some proportion of artificial variance in your data, which in turn it may produce erroneous results when you do the hypothesis testing. So what is SEM? So as I said earlier, in simple sense, the integrated version of your EFA and MLRM is nothing but structural equation modeling. And another way of understanding SEM is basically, this definition is coming from Hare et al. Book. So according to Hare et al., structural equation modeling is a collection of statistical techniques that allow a set of relationship between one or more IVs, either continuous or discrete, and one or more DVs, either continuous or discrete, to be examined. And here my recommendation is, even though in the definition they say that any sort of discrete variables can be considered in the same model, I would strongly recommend you not to consider this particular recommendation. As far as exogenous constructs are, exogenous variables are concerned, you can have discrete variables. But as far as DVs are concerned, you always try to have continuous or metric data points. Otherwise, there will be a lot of issues with respect to selection of the estimation technique, even with respect to getting the model fit values. So in SEM, basically, we try to test the theory. So how we are trying to prove that particular theory, there are different parameters we have to consider. So from this particular standpoint, always better to use metric data points wherever you are trying to implement path analysis as well as structural equation modeling. Sometimes the SEM is also referred as causal modeling approach, linear structural relations, causal analysis, simultaneous equation modeling, analysis of covariance structures, path analysis, and confirmatory factor analysis. So path and CFA are two special cases of SEM. Rest all other terms are used to refer SEM modeling. So this is the SEM model created using Amos graphics software. So when you look at this particular SEM model, so one side you have exogenous construct, that is work family conflict and family to work conflict. So all of these constructs are measured using 5 items, which in turn leading to job satisfaction and finally resulted in family satisfaction. So here family satisfaction is measured using 3 items and job satisfaction is measured using another 3 items. So this is the typical SEM model. So here simultaneously we are trying to estimate the path loadings as well as error values as well as the regression relationship among the constructs. Everything simultaneously we are trying to quantify. So that's the reason why we refer this particular framework as structural equation modeling. Clear? So try to understand why we need to use SEM. So this is the condensed version of entire Ullman paper. So if you look at this paper, you get more clarity in terms of understanding why we use SEM, what is SEM, and so on. And in SEM, as I said earlier, it's one of the best theory testing approach. So one side you have observed covariance matrix, another side you have the estimated covariance matrix. So what do you mean by observed covariance matrix? Theoretically speaking, let us say that one side you have the theoretical model, Another side, you have your data. Now you are trying to test that particular theoretical model against this particular data. If the data is well fitting with the model, so you get a really good fit for your data set. I mean, really good fit for your data frame. If you don't get good fit, which means that whatever you expected in the theoretical model, that is not actually happening in the given population. So this verification is done. This verification is usually done with the help of comparing our observed covariance matrix with the estimated covariance matrix. Observed covariance matrix is nothing but our raw data set. Estimated covariance matrix is nothing but the estimated covariance matrix that is reproduced after running the SEM analysis. And here also we try to understand the significant relationship that exists among the variables within the model. That also we try to quantify, and which nested model provides best fit to the data. So if you have multiple models on the basis of the same data or maybe different data, you can kind of compare each and every models with another model, and then with the help of the fit values and other criteria, you can also say which model is best fitting with the data. Then studying complex relationship among the variables. A lot of complex models can be very well estimated with the help of SEM. Then SEM explicitly take into account measurement error. That is one of the added advantage of using SEM. And according to Julia Pell 1988 citation, he argues that structural equation modeling allows us to test our ideas with non-experimental data under the assumption that a causal model is true. So whatever may be the theoretical model we are trying to use or we are trying to test, okay, whatever the theoretical model we are trying to test in our research, we assume that because those theoretical models are developed on the basis of some sound theory logic. And here we assume that based on this theory logic, we assume that this is the cause for this effect. So based on this rationale, any SEM based models can be considered as, robust, as well as you can also establish the cause and effect relationship based on this particular condition. In non-experimental data, establishing the causality is really difficult, impossible sometimes. Okay. Only in the case of experimentation, up to some extent we can establish the causality, but 10% causality nobody can establish. Okay. Even in experimentation also, we are not taking into account of all the possible causes which will affect your outcome. So if that is a scenario, if that is a condition, it's really difficult to establish the causality using non-experimental data. But based on this citation reference, we can justify that up to some extent, the model is causal in nature. And if you want to test mediation models, again, you can also use SEM. That is also possible. These are all the reasons why we use SEM. Now you just look at this paper. This is from Journal of Marketing. One of the best journal in marketing domain. So here they have a construct called perceived management support for CSR that is related to job performance through organizational identification. And similarly, this side you have perceived customer support for CSR that is in turn related to customer orientation and then job performance through employee customer identification. So if you look at the entire model, so this construct is measured using these three items. This construct is measured using these three items. So basically, this is how you will test your theoretical model using SEM. So in one go, simultaneously, everything you can test it. That is the beauty of applying SEM. And another beauty of SEM is in multiple linear regression model, you can't keep control variable for your X's. For your independent variables, you can't keep control variable. That provision is not available in what you call the multiple linear regression model. Whereas in SEM and path analysis, you can keep separate control variable for your X. You can also keep control variable for your Y. You can also keep separate control variable for M. Our same control variable can also control all of the constructs that is available in the model. That is very much possible in the case of SEM, whereas in the case of MLRM, that is completely impossible. Look at this reference. This is the typical reference one can use in terms of understanding the application of SEM. This is from AMJ, again, one of the really top tier journal in management domain. So one side you have cognitive style, POS for creativity that is related to creative performance through feedback inquiry and feedback monitoring. And here you have the regression weight between cognitive style and feedback inquiry. And the cognitive style is actually represented through C1, C2, C3. And you have got the factor loadings, and you also have the errors, Able to understand? So this is how you can estimate everything. And finally, you can also make some conclusion about the theoretical relationship that exists among the constructs as far as this theoretical model is concerned. Any questions so far? Able to understand? What happened? People are so silent.
Yes, sir, getting it, sir.
Fine. So are you getting something, or everything is looking like a Greek and Latin terms? Getting something?
Yes, sir.
Sir,
Yeah.
sir, can you explain the concept of control variable in SAM versus in multiple linear regression?
Okay, so what I'm trying to tell you here is, for example, if you look at this MLRM model, you can have, I'm trying to take the pen, it is not coming, just a minute. Once again, I'll try to reshare the PPT. I don't know the reason the pen is coming now. See, if you look at this MLRM model, if at all I want to keep some control variable here, for example, I'm keeping this as a control and I want to control it for X3. This is impossible in the case of regression. Whereas in the case of path analysis and SEM, you can have separate control variable for your PBC. Let us assume that this is my control variable 1, and control variable 2 is controlled for behavior, and control variable 3 is controlled for intention. Like that, you can also have separate controls for your mediators, outcome, and then your antecedents. Whereas in the multiple regression case, this is impossible. You can't do that. You can have as many as possible controls only for Y. Basically, those controls are nothing but another independent variable that is sitting in your independent variable umbrella. That's it. But if at all you want to keep some control for this X1 and X2, X3, impossible in the case of regression. Whereas in the case of path and SEM, you can have separate controls for even for your X, M, Y, and so on. Making sense?
Yes, sir.
Just look at this paper. This paper is coming from JAP. Okay, Journal of Applied Psychology, one of the top journal. So whatever the constructs here shaded, right? All those things are control variables actually. So here this newcomer proactive personality is used as a control to control commitment to task mastery as well as commitment to social adjustment. Similarly, supervisor proactive personality and social exchange relationships are controlled to control manager social information providing and manager task information providing, and co-worker task information providing and co-worker social information providing are acting as a controls for all of these outcomes. Able to understand? Making sense? So this is quite possible in the case of SEM, whereas in the case of regression, if you consider this manager task information providing as a DV, you can't have a control for your commitment to task mastery. That is impossible. I hope you know the assumptions of causality. One of the assumption is concomitant covariation. Second assumption is temporal precedence. And then the third assumption is alternate explanation. So in SEM, one of the added advantages, whatever may be the constructs or variables you feel like considered as alternative explanations for your outcome, all those alternative explanations can be measured and used as a control in your theoretical model so that you can estimate the true relationship between this construct, these two constructs, commitment to task mastery and manager information providing. Are you getting my point? Able to understand? If you need more details about control variables, I strongly recommend you to visit my page. This is my site address. I'll also copy paste the site address link in the chat. If you go to resources page, so here there is a heading called control variable. There is a heading called control variables. You start your reading from this Becker et al. Paper that will give you good clarity in terms of understanding the role of control variable in research. So I'm just sharing this link in the chat box. Fine, let me go back to the PPT. Fine, able to understand? Just look at this model. This is from MIS Quarterly. So to test all of these relationships, you just tell me how many regressions you are supposed to run. How many regressions you are supposed to run to test all of these relationships. Any idea? Can somebody guess? How many? Suppose if this is going to be your theoretical model, if at all you want to apply regression, how many regressions you will be using to test and quantify all the relationship that is there in the theoretical model? Any idea?
14.
How many regressions? 14 regression? Okay, then any other answers? Say some number. I'm not going to give any punishment, don't worry. That is the liberty, you can take it from outside faculty. Yeah, please feel free to share some numbers. Anything?
6.
6 regressions. Okay, then any other numbers? Any other numbers? Any other numbers?
8.
8. Okay. Then any other numbers? Still, I'm not getting the correct answer. So if I'm asking any other number, means I didn't get the accurate answer.
Sir, I think what I understood is that it may be possible how your model is basically looking into it. Is irrespective of
See,
number,
for
I think.
example, here information management capability is a key X variable that is related to customer performance, financial performance, human resource performance, organizational effectiveness through performance management capability, customer management capability, and process management capability. Okay. So here what I'm trying to understand is I'm trying to test all of these relationships. So if at all I have this model, suppose if you are planning to apply regression, how many regression analysis you are supposed to do? That's the question I'm asking. You are supposed to run 7 regressions. I'll tell you the logic. You just count the number of dependent variables. How do you identify something as a DV? Whenever a arrow is coming and ending with your entity, it's a dependent variable or endogenous variable. So here, performance management capability, customer management capability, process management capability, organizational effectiveness, HR performance, financial performance, customer performance, everything is endogenous constructs basically. Okay. So here you have 3, here you have 4. So 4 plus you are supposed to run 7 regression. How do we understand this? See, for example, this is going to be one of the regression. This is going to be second regression. This is going to be third regression. Able to understand? And as far as this construct is concerned, from here, from here, from here. So totally, this is going to be one of the regression. Already 3 regressions are over. This is 4th regression. And similarly for this construct, 5th regression, because there is a line coming from here, 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 and from here it is not coming. Similarly for rest of the two. So basically you need to run 7 different regressions for this model. Logic is clear?
Yes, sir.
Suppose if you to do regression for this path model, how many regressions you are supposed to do? How many regressions you are supposed to do for this model, path model? Any idea?
4, 5.
Two regressions, because you have endogenous variable 1, endogenous variable 2. So 2 regressions. So in the first regression, this 3 will affect intention. So here y is intention, x1, x2, x3 are attitude, subjective norm, PPC. In the second regression, behavior will be the DV, PPC, and then intention. This 2 will affect your behavior construct. So 2 regressions. Logic is clear? Making sense? For this model, how many regressions you are supposed to do? Any idea? How many you are supposed to do for this?
3.
6.
Yes, very good, very good. Because you have got 3 endogenous constructs. Now able to understand the logic? So feedback and inquiry will be Y, cognitive style PO is for creativity X. Then feedback monitoring is Y, cognitive style PO is for creativity are XS. Here for creative performance, all of these 4 constructs will be acting as X for this creative performance. Making sense? Logic is clear?
Sir, can you explain it one more time?
For example, you consider this feedback inquiry as Y. How many paths are coming and ending here? There is a path coming from cognitive style. Here, there is a path coming from POS for creativity. So basically, this will be your X1 and then this will be your X2. These 2 constructs are related to Y. So regression 1. Then you consider this as a Y2, that is another dependent variable. So how many paths are coming here? From cognitive style, there's a path coming. POS for creativity also, another path is coming. So this regression is your second regression. And for creative performance, there's a path coming from here. There's a path coming from here. And here also another path is coming. Here also another path is coming. So this is your third regression.
Okay, got it, sir. Thank you.
Logic is clear? Just look at this model. See the complexity of this theoretical model. So you can actually very well quantify the relationship that is available in the model, something similar to this. I mean, whatever may be the complications you have, so all those complicated relationships can be well defined and well quantified with the help of SEM. Now able to understand the capability of SEM? Making sense? And look at this paper. This paper is in the context of daily study, a daily survey. So there are some constructs measured on daily basis, and here something is measured only once. So this is referred as multi-level model in general. In multi-level context also one can use multi-level SEM. That is also possible. So here what they have used was one of the advanced approach called DSCM. DSCM is nothing but dynamic structural equation modeling. The dynamic term is something related to time series nature of data. Fine. Look at this model. Here they have used multi-level analysis because there are certain entities measured at the organizational level and then individual level. And then they have quantified all of these relationships using multi-level model or multi-level modeling. Clear? Then look at this paper. This is from Journal of Business Ethics. So look at the complexity of the relationship that is there in the model. So here also people have used SAM. Fine. Look at this paper. This is coming from Journal of the Academy of Marketing Science. Look at the complexity of this model. Here also they have used SAM. So now whatever we have discussed so far is just the general introduction to understand SAM. Suppose if you are trying to apply SAM in your research work, what are the process you have to follow? So the first thing is you first try to review the relevant theory and research literature to support model specification. So whatever the model you are trying to develop, you try to develop that particular theoretical model with the help of solid theory support. So unless you are developing your theoretical model without any theory support, at the end of the day, your model may not be fitting well with the data. There's a logic behind this particular saying. In my lengthy sessions, I used to spend a lot of time here, but here I'm not spending that much of time. So always theory support is one of the essential point. Second is you have to specify the model, diagram and equations. Third step is you determine your model identification. So now after this slide, I'm going to discuss something called confirmatory factor analysis. There I'll discuss something about what is degrees of freedom in SAM and model identification. So there's a separate slide devoted for it. So we'll have some discussion when I open my CFA slide deck. Then select measures for the variables represented in the model. So always try to make use of standard scales that is coming from the literature. Then you go for the data collection, do the data entry. So up to this fourth step, everything need to be done before the data collection. So once the data collection is over, I don't think so you will be able to do anything with respect to this point number 1 to 4. So all of these things can be, should be done before your data collection. So once data collection is done, then after that you do the data entry, coding, everything. Then you can also apply exploratory factor analysis if you want to understand the multidimensionality of your data. Or if you are using standard scales to measure everything, you need not to use EFA. Straight away, you can go and do your confirmatory factor analysis. So now I'll give you a bit of explanation to understand CFA. So what is CFA? So as I said earlier, CFA is a process where we are trying to validate our measurement model. So SIM is a two-stage process. First stage is you apply CFA and then you validate your measures and then you go and do your structural model testing. So it's a two-stage process basically. Fine. In many research work, researchers are interested in variables that may not be measured directly. For example, job satisfaction, organizational commitment, all of these constructs are measured indirectly using some of the standard scales. Are you getting my point? For example, if I open a scale to measure something, let me show you that. I hope you know the concept of using standard scales, right, for measuring anything. So I'm just typing work engagement scale in the Google Scholar and I'm getting a paper. So I know the core reference, but I'm just opening this paper. Just look at this reference. At the end of the appendix, at the end of the paper, they have given the 17 items to measure work engagement level of the people. So this is nothing but standard scale. Making sense? So when I use all of these proxy items to measure work engagement level of my people, so what is happening here is in CFA, basically I'm trying to validate whether my measures are actually capturing the intended portion of the construct. So as I said earlier, at the abstract level, construct is having some theoretical meaning. At the empirical level, we are trying to operationalize that particular construct, and then we are trying to measure it with the help of some statements and proxy measures or manifest variables. So once the measurement is over, I'm trying to verify, I'm trying to ensure that whether the measurement process is fine or not. That is what I'm trying to check. Making sense? So that is what I'm trying to do in the case of confirmatory factor analysis is concerned. Able to understand? Clear? What happened?
Yes, sir.
Yes, sir.
Yeah. So in CFA, basically these variables are often social science research work as well as management research referred as latent variable or latent construct. Already we had some discussion about this. And to measure a latent construct, we use proxy measures such as items or questions used in the questionnaire. So whatever may be the statements or items or questions available in our questionnaire, all those things are referred as proxy measures or manifest variables or observed variables or proxy items. And these items are referred as observed or manifest variables or proxy items. And researchers attempt to gain the information using observable variables because you can't directly quantify your people commitment level, your people buying intention, or your people loyalty level, and so on. So we use proxy items and then we try to indirectly quantify all those elements. We try to indirectly quantify all those elements. That is what we try to do in any psychological measurement process is concerned. Because for most of the psychological entities, we do not have secondary data. Suppose how many of them are attending this meeting, I have some secondary source of information because already that number is projected on the screen. But how do I understand whether, let us say, Mr. Ashutosh was satisfied with my class, or maybe Rupanjali is satisfied with my class? How do I get the detail? So I have to use set of items in my questionnaire to gather that information. Or directly, I can also have one-on-one interaction to gather some feedback about my session. Are you getting my point? So if I use direct one-on-one conversation, in some cases, it's really time consuming and costly in nature. That's the reason why we employ survey research to reach out to the masses, and with no time, we can able to get a lot of data from the survey, study participants. And these items are, exploratory factor analysis and confirmatory factor analysis are the statistical analysis techniques used to test the measurement theory against the data. One problem with the EFA is that we are not taking into account of the measurement error, and all the items are freely loaded on other constructs. Whereas in CFA, we as a researcher, we say that these are the items that should be loaded on certain constructs that we are trying to delineate in the case of CFA. We as a researcher, we define, okay, these are the set of items that is measuring this particular construct. That is how we are trying to model everything in CFA. In EFA, factors or later constructors derived based on the statistical results, whereas in CFA, factors are estimated based on measurement theory. EFA can be performed without knowing the factor structure, and in CFA, the analysis is performed after knowing the factor structure. After knowing the factor structure. In EFA, measurement error is not captured, but in CFA, measurement error is explicitly captured and estimated in the model along with the factor loadings. That's the beauty of CFA. These are the few differences between EFA and CFA. So as I said earlier, I think I also gave some explanation about CTT, right? Classical test theory. Classical test theory says that any observed score will have some proportion of true score as well as error. This error is again coming from two different sources. One is coming from sampling, another one is coming from the systematic sources. That systematic sources are classified into two parts. One is coming from the respondent side, another one is coming from the test administrator side. Social disability bias is a bias that is coming from the respondent side. For example, in this forum, if I ask Ashutosh to say or disclose openly something about his family income, he may be offended, right? He may not be sharing the correct number, right? Maybe just to maintain some peer, prestige level, he may be saying that I don't know, sir, exactly my family income could be anywhere around 5 crore or 10 crore. I need to talk to my father to get the exact figure. Okay. So he may be giving a wrong response here. Let us assume that Mr. Ashutosh's family income is actually only 20 lakh per annum, but he is giving some other fake figure just because of this social disability bias. Suppose if I ask Ashutosh openly, do you have girlfriend? He may be offended, right? Again, he may not be giving the correct information. So what I'm saying is these are some of the ways how error is getting accumulated in our data. I'll give you one more example to understand error. For example, I had a big fight with my wife today morning, and now you are forcing me to fill the questionnaire. Do you really think that I'll be in a position to fill your questionnaire in a better manner, or I'll be giving honest responses for your questionnaire? I don't think so. I don't think so. Able to understand? Making sense? So these are the few reasons why we get a lot of error in survey research. That is one of the fundamental reason why people left and right question survey research outputs. Especially the cross-sectional based designs and studies are no more, accurate, and none of the top-tier journalists accepting cross-sectional study-based evidences. So now if you look at the trend, current trend in at least in OB and psychology literature, you have to run experiment, you have to supplement your experiment findings with the help of some longitudinal studies or maybe some qualitative evidences and so on. That is how the literature is getting progress. In 80s, 90s, even up to 2000, 2010 also, 2015 also, I have seen some of the simple survey papers getting published in the AMJ level, but now no more they are accepting simple survey research based evidences in top tier journals. So what is model identification? So in SEM, the degrees of freedom formula is P into P plus 1 divided by 2 minus K. What is this P? This P is nothing but number of items available in our hand in terms of estimating the required number of parameters. So here this K is nothing but number of parameters to be estimated as far as our model is concerned. Whether it is a CFA model or path model or SEM model, it doesn't matter. So when you look at this job satisfaction constraint, so I've got only two items. I've got only two items, that is JS1, JS2. Okay, I've got only two items, JS1 and JS2. And this JS1 and JS2 are actually used to measure my job satisfaction constraint. And how many items I have here? I have only two items. I have only two items. If you substitute this 2 into this model, let us assume that I'm trying to run a CFA only by keeping this particular constraint. Okay. If that is the case, I'm going to estimate four different values here. So two error values and then two loadings. These are the four different values I'm going to estimate. But how many information I have in my hand? I've got only two information. If you substitute 2 into this model, 2 into 2 plus 1 divided by 2 minus k. Okay. So 2 into 2 plus 1, how much you will get? 6 divided by 2, 3 minus 4. How much you are getting? Minus 1 as the degrees of freedom you are getting. If the degrees of freedom is 0 or minus 1, I don't think so. You will be able to estimate your fit values. Are you getting my point? So practically, how do we understand this explanation? For example, at IIT Guwahati canteen, single lemon chaya cost is 15 rupee. Single lemon chaya cost is 15 rupee. But Ashutosh is having only 10 rupees in his packet. So he can't afford to buy the chaya. That is called under identification, which means that you will not be able to estimate the model parameters. In just identification case, for example, for this model, I'm trying to do the CFA. So I've got three items here, JS1, JS2, JS3. Okay, I've got three items here, JS1, JS2, JS3. And if you look at this particular construct, how many parameters I'm going to estimate? Here, three errors, three loadings. If you substitute this 3 into this degrees of freedom formula, you get 3 into 3 plus 1 divided by 2 minus 6. That is the value. If you solve this, 3 into 3 plus 1, so 3 into 4, basically 12, divided by 2, you get 6 minus how many parameters you are going to estimate? 6. So your degrees of freedom is 0. Your degrees of freedom is 0. So how do we understand this practically? Let us assume that Mr. Ashutosh is having only 15 rupees in his pocket and lemon chaya cost at IIT Guwahati canteen is only 15 rupees. So he can buy the chaya. So this scenario is referred as just identified scenario. Even in this case also, getting some of the model fit values are difficult because in most of the cases in the denominator part, we use degrees of freedom as one of the key input to compute some of the fit values in SEM. And in the case of over identification, so let us assume that for this particular diagram, I'm going to run the analysis. So here, how many items I have? 4 items I have. So you substitute 4 into this formula. 4 into 4 plus 1. 20 divided by 2, 10 minus how many parameters you are going to estimate? 8 parameters you are going to estimate. 10 minus 8, you get 2 as a response. So your degrees of freedom value for this particular model is positive 2 plus 2. Able to understand? So how do we understand this practically? Mr. Ashutosh is having 20 rupees in his packet and lemon chaya cost is only 15 rupee. In additionally, he is having another 5 rupee in his wallet. So this problem, this scenario is referred as over identification scenario. Over identification scenario. Up to this, able to understand? Any questions in terms of understanding model identification? Any questions?
No, sir.
Fine. So if you look at measures, constructs, already we had some discussion about this. And you do have some concepts like formative construct and then reflective construct. So any idea about formative and reflective constructs? Any idea? If you are completely new to understanding reflective and formative construct, you please start your reading from this paper. And if you look at formative construct, there's a paper coming from Psychological Methods, Edwards and Bahosi paper. So this paper will give you solid understanding on understanding what is formative construct and then reflective construct. And if you go through this paper, you get good clarity. So if you look at this paper, so here you have the reflective measurement approach. You consider this as a construct and you have got 3 items to measure this construct. This lambdas are nothing but loadings basically. And here you have this errors. Okay. But if you really look at this arrow, this construct is actually reflected or represented on the basis of this x1, x2, x3. Reflected or represented on the basis of this x1, x2, x3. Are you getting my point? Able to understand? Making sense? This is called reflective measurement approach. In reflective measurement approach, we assume that the items are highly homogeneous in nature and the items will have high level of correlation among each other and measurement error is occurring at the item level. Item interchangeability is possible. Even item deletion is also possible. In most of the CB SEM case, we have when we do the CFA, if 1 or 2 items are producing really poor loading means we tend to remove that particular item from the model. Nothing will happen. Nothing will happen because we use redundant item to capture the same constraint. Making sense? Able to understand? So this is called reflective measurement. In the case of formative measurement, your model will be looking. So this construct is formed or measured and formed on the basis of this x1, x2, x3 scores. For example, in strategy research and finance research, we use Tobin's Q to measure firm performance. We use Tobin's Q as one of the indicator to measure firm performance. Okay. So Tobin's Q is actually calculated on the basis of different financial record information like market share and so on. So it's a formative nature. Firm performance is formative in nature as far as that particular approach is concerned. In formative measurement approach, your items are unique in nature. Your items may not be having really proper correlation among each other, and your measurement error will occur at the construct level, not at the item level. And your items are used to form your construct domain. Item interchangeability is not possible. Item deletion is also not possible in the case of formative construct is concerned. Able to understand? Making sense? And once you are
Yes,
done
sir.
with this reading, next you can also refer this particular paper. You refer this Jarvis et al. Paper, a critical review of construct indicators and measurement model misspecification in marketing and consumer research. So this paper will give you better clarity in terms of differentiating reflective measurement approach from formative measurement approach. And if you look at this paper, there is a table available after few pages, this table 1. So if you go through this table 1, you will get to know the differences between formative and reflective measurement approach. So I'm just sharing this paper link in the chat box. I'm not going to spend much time here in terms of explaining both the paper contents. Making sense? Fine. So now let me go back to my PPT. So if you look at reflective and formative constructs, this is how it will be looking. This is formative in nature, this is reflective in nature. Then you have one more type of construct that is nothing but reactive indicator. But hardly you see some references from the literature to understand reactive indicator. So I'm not going to spend any time here. Reactive indicator approach, your construct will cause the item. Also your items will cause the construct. That is reactive indicator approach. And the sample size consideration in CFA and SEM studies. So I strongly recommend you to have a larger data set, larger sample whenever you are trying to do something related to CFA and SEM. So as far as CFA and SEM is concerned, according to Hairbook citation is concerned, 1:10 is the ratio highly recommended. 1:10 is the ratio highly recommended. I would strongly recommend you to at least keep 1:5 as a ratio. What do you mean by 1:5? Suppose if you have a single statement in your questionnaire for which you have to gather 5 responses. If you have 50 items in your questionnaire, 50 in 5, at least you need to have 250 responses. At least you need to have 250 responses in your questionnaire. That is what 1:5 versus 1:10 ratio. Fine. And the core reason why we do CFA is we try to understand the construct validity. We try to establish the construct validity. So the construct validity is nothing but in simple sense, you at the theoretical level, you have something to say about that construct. At the empirical level, we have quantified that particular construct. Whatever we have quantified, whether that quantification is best capturing the construct domain or not. Suppose if that quantification is best capturing the construct domain means there is no concern of validity. Okay, so you have accurately measured everything. If whatever you have measured, if that is not going to represent your construct domain, which means that some difference is existing here. So whatever you have expected at the theoretical level, same thing is not being captured at the empirical level. That is how you can understand this. So as far as construct validity is concerned, literally it is defined as is the extent to which a set of measured items reflect the theoretical latent construct they are designed to measure it. And the construct validity is established on the basis of these 3 types of validity. One is face validity, second one is construct validity, and then convergent validity, and then the third one is discriminant validity. So as far as face validity is concerned, usually in scale development process, on the basis of the judgment, on the basis of the expert opinion or expert judgment, we try to establish something about face validity. And the convergent and discriminant validity are statistical procedure. We use in our CFA analysis in terms of establishing all those things. So as far as convergent validity is concerned, it is referred as the extent to which indicators of a specific construct converge or share a high proportion of variance in common. This convergent validity logic is applicable only in the case of wherever you are trying to quantify or wherever you are trying to test the validity of your reflective constructs. This logic is not at all applicable with respect to quantifying or testing anything related to formative constructs. Okay. And convergent validity is established based on average variance extracted. So AV formula is given here. So sum of lambda square divided by n. These lambdas are nothing but loadings. The loadings which is being produced in the CF analysis. So according to Hairbook citation is concerned, if this AV value is above 0.5 means you can say that up to some extent convergent validity of the model is established. We not only look at only the AV value, we also look at AV value, factor loading significance value, and then whether the factor loadings are above 0.5 and so on. And in addition to that, we also look at construct reliability or composite reliability. This construct reliability or composite reliability is referred as McDonald's omega value. McDonald's omega value. So this McDonald's omega value must be above 0.7 according to Hairbook as well as other literature references are concerned. How do you estimate this? So you take out the factor loadings that is being produced in your CFRN and you square, you take the sum of all the lambdas and then you square it divided by sum of lambda whole square plus sum of errors. So you take the, you get errors for each and every items. I'll show you how to manually compute this using Excel, and then I'll also give you some shortcut methods how to estimate everything in, without any time limitation. Discriminant validity is one of the important components. The reason why we try to establish discriminant validity whenever we apply SEM is, since we are trying to establish cause and effect relationship among the constructs, you need to say that my constructs are theoretically related but distinct from each other. How do you say? See, for example, this side I have job autonomy, and then my final outcome is, let us assume that job performance. Through organizational commitment, I'm trying to test something. Okay. Here, all of these constructs are theoretically related but distinct from each other. What do you mean by distinct from each other? Unless you say that the constructs are distinct from each other, how do you say that this is the cause for this effect? Based on this logic, we use different approaches to establish the discriminant validity. One of the well-established and age-old concept is MTMM approach, that is multi-trait, multi-method approach. So for this, you need different levels of data. Usually now, considering the current limitations and other things, it is kind of impossible to establish discriminant validity using this particular method, for which you need to have a exclusive design. And we use often in CB SEM literature, Furnell and Laker criterion to establish the discriminant validity. So according to this particular criteria, your average variance extracted value, okay, you take the square root. The square root of AV value must be greater than the inter-construct correlation values. Suppose if the square AV values are greater than the inter-construct correlation values, means you can say that the discriminant validity of the model is well established. Or you take the raw AV values and then you just compare it with the inter-construct correlation values. If the raw AV values are greater than the squared inter-construct correlation values, means you can say that the discriminant validity is established. Mathematically, both the approaches are same only. Either you take square root here or you take square for the inter-construct correlation value, both are same only. And now if you look at the recent literature, we use another approach called single factor model, two factor model, three factor model, four factor model, and so on. This also I'll show you how to do it in while running the CFA analysis using AMOS. This is one of the recent approach. And in CFA, we must fulfill some of the fit criterions. So one is, I mean, as far as the goodness of fit indices are concerned, we look at GFA value, that is goodness of fit index. We also look at EGFA value, adjusted comparative fit index. Then you have NFA value, normed fit index. Then you have CFA value, that is nothing but comparative fit index. All of these values must be greater than 0.9. Then you have badness of fit indices. As far as the badness of fit indices values are concerned, it should be less than 0.08 according to this book citation. And as far as model comparison is concerned, we use AIC value, BAC value, and then CFA value for model comparison purposes. And in the recent version, 2017 version of Hare book, Joseph Hare also proposed a new metric called adjusted theoretical fit index, ATFI. So how do you estimate this ATFI? So you have CFA result and then you have the SEM results. From CFA results, you take the comparative fit index value. Also, you take the CFA values from the SEM result. And then you take the CFA value from CFA. You just apply all those values here into degrees of freedom coming from the theoretical model, degrees of freedom coming from the CFA model. And if this value is closer to 0, if this value is closer to 0 means your model is exactly fitting well with the data. Basically, for comparing the fit values of your CFA and SEM, we use this metric. So these are the few metrics we use in terms of assessing the CFA as well as SEM model when we do the analysis. Any questions? Any questions? Clear?
No, sir.
No, sir.
Fine. So shall I ask some questions? So everything is clear. No, you try to explain this slide to me. I'm just joking. Can you get something out of this slide? Can you get anything out of this slide? You're seeing something similar to this diagram. This one, and this one. Any research scholars sitting here from management or psychology domain? Anyone?
Yes, sir.
Okay, fine. So any idea about the slide content? No idea. Okay, due to lack of time, let me clarify this. So this is nothing but your CFA model, confirmatory factor analysis model. Okay. If you have three constructs, let us say S1, S2, and S3. Okay. If all of these constructs are unidimensional in nature, see, I have not discussed anything about multidimensional construct here as part of this session. If all of these constructs are unidimensional in nature, this is how we create the CFA diagram, and then you run the CFA, and then you can check the validity, reliability. Also, you can assess the model fit values. And this model is referred as bifactor CFA, bifactor, BIFACTOR, bifactor CFA. So in the bifactor CFA, especially whenever you have multidimensional constructs, those dimensions will be modeled like this. So you will have a general factor and then specific factors. And there are some unique advantages are available with respect to running bifactor analysis, especially in the case of scale development processes concerned. Then you have this model is nothing but exploratory structural equation model. Exploratory structural equation model. So here what is happening is it's a typical CFA diagram, but we just connected all of the items with all of the constructs. This approach is nothing but exploratory SEM. Exploratory SEM. The reason why we do this exploratory SEM is whatever may be the item that is being used to measure this S1 construct, only in these three lines you get better loading. In all other lines you get poor loading. Through this way also you can filter the items. Through this way also you can validate your measurement model. That is possible. These are some of the recent approaches or maybe advanced approaches. Then you have something called bifactor ESEM. So here you have general factor, specific factor, also the exploratory SEM logic is also embedded within this bifactor model. So this model is referred as exploratory structural equation modeling bifactor model or bifactor ESEM model. Lot of papers are available in the literature to understand this. I can recommend this paper to understand this application, this concept application. See, just look at this paper. This is from Journal of Management, bit old only, 2016 paper. So here they have applied CFA, ESEM, bifactor, SEM, and then bifactor ESEM. All of these models are applied to validate this motivation scale. And here you have the results of all of these models. This ICM CFA is our traditional CFA. ESCM is nothing but exploratory sum. Bifactor CFA is nothing but bifactor CFA. Then here you have bifactor ESCM. Making sense? So for more details, you can go through this paper. So that's all about CFA. Now coming back to SEM slide. So once CFA is done, you go and test the structural model. So all of these things need to be done during this stage, 8th stage, and then you go and do the SEM model testing. There are certain assumptions need to be fulfilled while testing the SEM model. Include control variables. If you have something in your theoretical model, then you can test the mediation or you can test the interaction effect. Then later you can go and report your findings. Finally, you tell your story to the audience. Here also we have to use certain fit values. Same fit value slide is copy pasted from the CFA slide. So there are no other changes here. Here also we follow same logic. So in conclusion, SEM is used to confirm theoretical structures free of measurement error because it has been estimated and removed, leaving only common variance. Very complex and multidimensional structures can be measured with SEM. SEM programs allow calculation of modification indices, which help researchers to fit the model to the data. And we must also point out that SEM is based on covariances that are not stable when estimated from small samples. At the same time, having too large a sample size will also deteriorate your model fit values. So this is what the conclusion. And these are all the different softwares available in the literature. And for this session, we are going to use SPSS AMOS. Fine. So any quick questions from the audience side? So yesterday I have shared this particular link, right? I hope you would have received the data set as well as the paper associated with this data set. So if you look at this data set, before that, let me show you my paper. This is one of my old paper. It's simple SSA journal paper only, not so-called A star category paper. So in fact, here I have used PLSM, but here also I have used CFA to estimate the model, establish the model validity, because on the basis of the reviewer comment, we did this CFA analysis for both the samples. If you look at the theoretical model, job satisfaction, family satisfaction, feelings of work-family balance, life satisfaction, these are all the constructs now I'm going to use. So what I'm going to do is I'm going to replicate this particular section of the model. I'm going to test this particular section of the model. This is the model now I'm going to test in front of you using AMOS. And if you look at the data set, here you have some demographics like gender, age, marital status, and then education. So these are all the demographics you have. Then this JS1, JS2, JS3 are nothing but job satisfaction items. FS1, 2, 3 are nothing but family satisfaction items. LS 1, 2, 3, 4, 5 are nothing but life satisfaction items. And then work family balance 1, 2, 3, 4, 5 are nothing but work family balance items. And then you have the average scores for all of these four constructs. And then you have the average scores for all of these four constructs. Clear? Making sense? So now to test the model, you just open Amos graphics software. So are you going to do the analysis parallelly along with me, or you want to listen first and then you want to replicate later? So any suggestions from the participant side? What happened? Nobody is opening their mouth.
So we'll do together.
Sorry?
So we'll do the analysis along with you.
Okay, fine. So if that is the case, I hope you have access to Amos graphics software, right?
Yes, sir.
Okay, then you open you before that you check your previous email, I mean yesterday's email. There you have the OneDrive folder link. You just download the folder. You just download the folder. Okay. After that, you unzip the folder so that you will be able to get the three files. So now I'm going to import this work family balance SPSS data file into Amos graphics. Okay. Before that, after opening your Amos graphics software, what you do is you go to view, click interface properties. So here it will be by default portrait letter format. Instead, you select landscape A4 format. Instead, you select landscape A4 format. Click apply so that your window will be expanded further. Yeah, I think someone has raised their hand. Any question?
Yes, sir. How Amos can be added with SPSS, sir?
No, you need not to add anything with SPSS. If you would have installed Amos in your machine, you just type Amos graphics or Amos, you will get this window.
So that has to
Or,
be previously need to install.
yes. Otherwise,
I
otherwise,
only have SPSS software.
yeah, otherwise, if you have SPSS, okay, you
Yes.
just go to analyze and check
Analyze.
whether this IBM SPSS Amos option is coming.
Okay, I will check, sir.
If it is coming, then you can click that particular option. Are you getting the point? Able to locate it?
I am trying, sir. 1 minute.
Fine. Any response from others? Any response from others?
Yes, sir, done.
Fine.
Done, sir.
So after opening Amos, what you do is you just go to view, click interface properties. So here instead of portrait, you select landscape A4. You select landscape A4 and then click apply. Now you will get better window. I mean, window size will be even more bigger than the previous window. Okay. So now what we are going to do is we are going to import the data set. How do we import the data set? You just go to analyze, select data file menu. So this is nothing but select data file. Can you able to locate my cursor on the window? Able to see the cursor movement? Yeah, Shyamala, any question?
Yes, sir. I want to ask. I have opened the SPSS. So what next I should do, sir? 1 minute. Sorry.
In the SPSS, if you
Yes.
go to analyze,
Yes,
are
sir.
you able to find IBM SPSS Amos option?
No.
If it is not coming, which means that you have not installed the Amos software in your machine.
Yes, yes, not installed.
Okay,
Yes, yes. So that,
making sense?
yes, yes, I understood, sir. For that, how can I download? Means how can I? It's any plugin or any extra software?
No, Amos is a commercial software basically.
Oh,
Okay.
okay.
So if at all you want to install Amos, you have to procure Amos. That's the problem with using Amos. That's the reason while starting the session also I gave some explanation about using our platform. So maybe you check with your lab. I think at IIT Guwahati they would have subscribed Amos also. If it is not there, you just follow me. There are some 10 minutes, 5 minutes videos also available in my YouTube channel. So you can also refer it so that easily you can get everything. But now you try to understand everything, whatever I'm going to explain. Clear?
Yes,
Fine.
yes.
So once you, how about others? Are you comfortable in terms of opening Amos? How about
Yes, sir.
others? Fine.
Yes, sir.
So now the next job is we need to import the data. I mean, we have to connect the data with the software. I think someone else also raised their hand. Yeah, anything?
Yes, hello, sir.
Yeah.
Those who have not installed the software, please don't worry. We are recording the session and we can
Yeah.
rotate it to you and you can have that. In the meantime, you can look for the trial version of the software that is available.
Yes.
And if not,
Yes.
please wait for it unless we are rotating the recorded session. Thank you, sir.
Yeah.
Now you can continue.
Yeah. Fine. So now to connect the data, my suggestion is you go to this select data files, click data files, click file name, and then you locate the folder where you have saved the data. So my folder, local drive folder is this one, data. So I'm just retrieving WFB dataset. After importing the data, you would be able to get this option 294 because 294 rows of information is available in my dataset. Click OK. Now the dataset is connected with my Amos. And when you click this list variables in the dataset option, it will show you the variables or items that is there in the dataset that is available in the current dataset. So all those things you can get it through this particular window. Okay. So I think in the Excel I have shown the same thing, right? Gender, age, marital status, education level. Then this JS1, JS2, JS3 are nothing but job satisfaction items. FS1, FS2, FS3 are nothing but family satisfaction items. Then LS1, LS2, 3, 4, 5 are nothing but life satisfaction items. Then we have work family balance. WFB 1, 2, 3, 4, 5 are nothing but work family balance 5 items. So these are the items I have in my variable box. Clear? Making sense? Next, I'm going to do the CFA. So I have shown that this is the model I'm going to test. Basically, I've got 4 constructs in my model. So I'm going to create a diagram, something similar to this in my Amos window. First, I'll run the CFA and then I'll go and do the SEM analysis. So that is what I'm going to do now. Clear? So first to do the CFA, what you do is go to Amos. So this option is nothing but latent construct option. You select this. Only for the first time, what you do is you just left click your mouse, drag it like this. You create this oval symbol, release the left click button, and then you move the cursor over the circle. You press left click button 1, 2, 3. So this construct is going to be my job satisfaction, which has got 3 items. So I just created this latent construct here. Now again, don't create your circle. Simply you just move the cursor here, left click one time, second time, third time left click, fourth time left click. So you will get all of these 3 items. This is for family satisfaction. Now I'm going to create something for work family balance, which has got 5 items. So I have created 5 items here. And then for life satisfaction, I'm going to create 5 items. So here I have created 5 items for life satisfaction. So this is the way how you can create the latent constructs in your Amos window. Up to this, any questions? Are you able to do this activity?
Sir, could you
Yes, sir.
repeat that left click thing which you said? I was not quite able to follow it.
Okay,
The way
I'll show you once again. I'll show you
Okay.
once again. I'm just removing this and then I'll do it once again. See, you select this latent construct, left click, you move the cursor here in your mouse, left click, okay? After clicking this latent construct, this will be highlighted. Able to see the highlighted portion?
Yes, sir.
Now you move your cursor, mouse cursor to the main window, okay? Now you once left click, 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 click. Left click only. So your latent construct will be created.
Okay, sir.
Are you getting the same?
Yes, sir. I'm trying.
So how many of you are using Amos at this moment and parallelly doing something along with me? Can you just raise your hand? 1, 2, 3. So far I got only 3 responses. 4, 5. 5 responses. The question is, how many of you are simultaneously using Amos, also following me, also doing this creation? Yeah, 6. So far I got only 6 responses. Well and good. That's fine. Great number. Okay. So now the next step is we have to connect our variables with our constructs. Now we have to connect our variables with the constructs or maybe observed variables. Basically, we are trying to map our data set with the constructs. How do we do that? Okay. There are 2 things. The way how you can do this is you can write down this JS1, JS2 within this box, or you just go to this particular variable listed in dataset view, left click, select that item, come to the box, release your left click. So now what happened was I could able to transfer this JS1 item into this particular observed variable box. Okay. Similarly, I'm just dragging JS2. Select, left click, hold the left click button, drag it, and then you locate this place. Now you release your left click mouse button. So I have successfully placed job satisfaction item 2 here. Similarly, job satisfaction item 3. Similarly for FS1, left click, hold your left click, move your cursor here. After locating the exact location, release the cursor. Similarly, FS3. Now this is for LS1, LS2, LS3, LS4, and then LS5. Now work family balance 1, work family balance 2, balance 3, 4, and then 5. So now successfully I have connected all of my variables into the variable boxes. Up to this able to do?
So while I'm drawing this latent variable, there is a difference in your figure. The circles, the ovals are separated. In my figure, the ovals are coming as they are intersecting with one another.
Can you just share your screen and show me quickly?
Uh,
I don't know whether sharing rights is available with everyone.
um, Yes, I am trying.
Can you just share?
Yes, sir, just a minute.
Yeah.
Now, tab, window. Okay. So I have clicked on the share button. Kindly see if it is visible.
Yeah, it's visible. Yes, that's fine. That's fine. So you have created a big diagram. Because of that reason, the errors are intersected. So that's fine, not an issue. Otherwise, you go to file new and then you can create a shortened version of this picture. That is also fine.
Okay, okay. Okay,
Fine,
thank you,
ma'am?
sir. Yeah.
Yeah. So now let me share my screen. Okay. So now the next process is what you are supposed to do is you need to give the name or labels for your latent construct. You have to provide the names or labels for your latent construct. How do you do it? So for example, I'm just moving my cursor here, left click, double click I'm doing. So object properties box is opening. So here I'm just typing this construct name as job satisfaction. So here family satisfaction. Similarly, I'm placing the cursor here. I'm naming this as a work family balance. So here I'm naming this construct as life satisfaction. So now I have given the labels. I mean, I'm done with the naming ceremony for almost all of my constructs. Up to this clear? Able to understand?
Yes, sir. Yes, sir.
So next what we need to do is we need to type the error terms. So you need not to type one by one. Instead, what you can do is you just go to plugins, click name unobserved variables. By default, system will allocate E1, E2, E3 everywhere. By default, system will allocate E1, E2, E3 everywhere. So now all the namings are done. I mean, the data set is connected with the model. Naming ceremony also over. Now next job is, as far as CFA assumptions are concerned, all the constructs need to be covaried together. All the constructs need to be covaried together. So how do you do the covariation? So what you do is you just select this single finger symbol, select the single finger symbol, come here, select this construct. After selecting, it will be highlighted in blue color. It will be highlighted in blue color. Now you go to plugins, click draw covariances. Now all the covariances will be drawn among the constructs. This part is clear?
So can you please repeat, sir?
Okay. See, after naming the error terms, you select this. Okay, just a minute. So after naming everything, what to do is,
Sir, can you please tell us how to name these error terms?
so for naming this, you just double click, you get this object properties. And then you just type the construct name. You should not use space, you should not use hyphen, you should not use any of the special characters. Okay, just type job satisfaction. Here you just type family satisfaction. Here you type work family balance. Here you type life satisfaction. This is how you can type everything. Making sense?
Yes, sir.
And then you go to plugins, just click name unobserved variables. So now everything will be filled here. Now everything will be filled here. Now to draw the covariances, what you do is you go to the single finger symbol. You select the single finger symbol. Okay. Select JS, FS, WFB, LS. So now everything is selected. Now everything is selected. Making sense? So once it is done, what you do is you go to plugins, just click draw covariances. You go to plugins and then click draw covariances. Able to do it? So once you do this, automatically system will allocate covariances among all the constructs. Making sense? Clear?
Yes, sir.
So now you can select this symbol. There's a symbol available here, right? This is nothing but deselect symbol. This symbol is nothing but deselect symbol. So when you select this, so all those selections will be disappeared. Now everything is looking in black color. So now we are done with the creation of the CFA model or CFA diagram. Clear? Up to this, any questions? Up to this, any questions?
No,
Shall I
sir.
proceed? Shall I proceed further?
Yes, sir.
So next what you do is you go to this option, calculate estimates. Before that, you go to analysis properties. So here in the output, you select standardized estimates. You ask for modification indices. So here you select standardized estimates and then you ask for modification indices. And then you close this dialog box and then click calculate estimate. It will ask you to save somewhere. So now I'm going to save this in IITG file data. So within this data folder, I'm opening another folder so that you can access whatever I'm saying here. Okay, because data folder link is already shared with you. So you can also download this folder. So CFA and SEM. So here I'm going to save this model as CFA model. Click save. Now your model is estimated. If you get this red color upward arrow, which means that the model is estimated, now you have your estimated results in your hand. So how do we infer this? So you go to text output. The first thing
Sir,
is you
please
check.
repeat analysis
Yeah.
properties.
See, you go to analysis properties. In the output, you select standardized estimates, modification indices. Able to do this? Fine.
Yes, sir.
Next, you close this, click calculate estimate. So when you click calculate estimate for the first time after creating the model, it will ask you to save this picture somewhere in your local drive. You select the location wherever you have saved your data or some other location also fine, but you must save this. You must save this somewhere in your local drive. Fine.
Sir, which one is outlet estimates?
This one, calculate estimate. calculate. Able to see the cursor now? Fine. Able to understand?
Yes, sir.
Yes, sir.
So now model is estimated. Now if you click this view text output, able to see this view text output option here? Able to see this view text output option? Click this view text output option and you get chi-square value, degrees of freedom value. So how are we getting this 98 as a degrees of freedom value? Try to understand this logic. So in our model, how many items are available? Here 3, 6. 6 plus 5 plus 5. Totally 16 items are available. Okay. So totally 16 items are available. How many items we have? 16 items. How many parameters we are going to estimate? Basically, we are going to estimate 16 loadings. Okay. And then we are going to estimate 16 errors. We are going to estimate 16 errors. And then how many correlations we are going to estimate? 1, 2, 3, 4, 5. 5 correlations we are going to estimate. So correlations are 5 correlations. Able to understand? Now totally how many parameters you are supposed to estimate here? The sum of these 3. 37, sorry, 6 correlations. I missed one. So totally 38 parameters you are going to estimate. Correlation 1, 2, 3, 4, 5, 6. This correlation I missed it. So totally 6 correlations you are going to estimate. So totally 38 parameters you are going to estimate. This value is nothing but K. This 16 is nothing but your P value. Okay. So what is the degrees of freedom formula? P into P plus 1 divided by 2 minus A. This is the formula for degrees of freedom in CFA or SEM. So now I'm going to do this estimation equal 16 into 16 plus 1 divided by 2, okay, minus K, 38. So let me close this bracket here so that this will be estimated separately. Now you see the answer. It is not producing. Here I have some formula. That is one of the reason why it is not taking. Anyway, that's fine. See, 16 into 16 plus 1 divided by 2 minus 38. 98 is the answer you are getting. Same 98 only in the output also we got it as a degrees of freedom. Now you able to understand this logic?
Yes, sir.
Clear? So now the next thing is you go to estimates. You look at the standardized regression weights. The standardized regression weights are nothing but the factor loadings. The standardized regression weights are nothing but factor loadings. So as far as this factor loadings are concerned, it should be above 6. It should be above 0.6. If it is above 0.6, you can expect that your AV values are coming good. Otherwise, you will have an issue with respect to your AV value as well as construct reliability or composite reliability value. So as far as my standardized regression weights are concerned, I'm getting proper values here. So there are no issues. So next, what I need to do is, if you look at the job satisfaction items, I'm getting 0.8, 0.8, 0.7. So none of the value is less than 0.6. So which means that I have good factor loadings. Now you go and check the above table whether all the loadings are highly significant. Yes, it is significant. Now you go to model fit, look at the C minimum divided by degrees of freedom value. The C min divided by degrees of freedom is nothing but your chi-square value divided by degrees of freedom, that is coming around 2.048. And you have GFA and then IFA, CFA, RFA values. So all of these values are above 0.9. So there are no issues. Then if you look at RMSEA, as far as RMSEA value is concerned, I'm getting 0.060 as a value. So the cutoff limit is, it should be less than 0.08. So there are no issues with respect to my RMSEA values are concerned. So this is also really good. So there are no issues with respect to model fit values. There are no concerns with respect to my factor loadings also. Up to this clear? Making sense? So next, what you need to do is, you have to estimate the AV values, everything. So for that, what you can do is, I'm just copying this table. Just look at the Excel, the way how I'm going to do the calculation. So I don't need this 2 rows of information. Let me get rid of this. And this also I don't need. So now I have the loadings here. So this are nothing but my loadings. So to compute the AV value, if you look at the formula for AV, so this is the formula for AV. Sum of loading square divided by n. So you have to compute the loading square and then you have to sum each and every loading square at the construct level and divided it by number of items. So how do you do it? So for example, I'm going to create loading square value here equal to this one multiplied with this one. So I get the loading square value. Okay. Next is AV value. AV is nothing but average of this 3 values. Similarly, average of this 3 values. Average of this 5 values. Here you have to expand this selection. Okay. Similarly, average of this 5 values. This is how you get the AV values. Now to compute the CR values, you need error values. Where do you get error values? From the system results you can get. Otherwise, 1 minus this lambda square will give you the error values. 1 minus this loading square will give you the error values. So you just drag this for all the items. This all the measurement error values for each and every items which I have considered are included in my CFA model. Now, if you look at the CR calculation, construct reliability calculation, sum of loading whole square divided by sum of loading whole square plus sum of error. So we have loadings, we have errors, but we don't have the sum of loading whole square plus sum of error values. So that you can calculate it simply using this logic. Sum of loadings square and then sum of errors. Able to see the formula? Sum of loading whole square plus sum of errors. So now let me compute the sum of loading square. So I have the loadings here. So equal sum function, sum of this 3 loadings. Okay. Cap 2. So this is nothing but sum of whole square load. Sum of square to loading. Now you copy this paste it here, copy this, paste it here, and select this 2 more items, copy this, paste it here. So now we got the sum of loadings whole square. Now you compute the sum of errors. So here I have my sum of error values. Okay. Now you can compute the composite or construct reliability values. How do you do it? Equal to sum of loadings whole square divided by sum of loading whole square plus sum of errors. Sum of errors. So this is how you can compute the construct reliability or composite reliability or McDonald's omega value. Any questions? So this document also, I'll save it in the data folder so that with the formula, you can access everything. With the formula, you can access everything. Making sense? Able to understand?
Yes, sir. Yes, sir.
So now what I'm going to do is, I need to establish the discriminant validity. To establish the discriminant validity, I need correlation values, I need AV values. Here I have the AV values, I need correlation values. From where you will get the correlation values? Just go to the output page. If you scroll down, here you have the correlation values. These correlation values can be arranged in the form of a matrix, and then on the diagonals, you can keep the square root of AV values. Through that way, you can manage the show manually. So manually, if you're going to create this, how do we do it? So you just copy this correlation table. Okay. You just paste it here. This is what raw correlation, right? And my constructs are JS, second one is FS, third one is WFB, fourth one is LS. Similarly, in the columns, you keep 1, 2, 3, 4. Basically, what I'm trying to do here is I'm creating the correlation matrix. So this 1 and 1, no logic, so no correlation. This 1 and 2, that is job satisfaction and family satisfaction, the correlation is this one. Okay, this value. Then work family balance and job satisfaction, the correlation is this value equal to this value. Then job satisfaction and life satisfaction. So here is the correlation. So this correlation is this one. Similarly here 2, 1, no logic, 2, 1, 2, no logic. This correlation is 2, 1, 3. 2 is my family satisfaction and then work family balance. So this value is coming from here. And then 2 and 4, that is family satisfaction and life satisfaction. So this value is coming from here. And then I have got one more remaining value. That value is nothing but this one. That is life satisfaction and work family balance. Now I kind of created the correlation matrix. So now I can copy this correlation matrix. I'll paste it here as a values. I'll paste this as a values here. Okay. So now I have the interconstruct correlation values arranged in the form of a matrix. So now I need to populate the square root of AVs here. So for job satisfaction, the square root of AV value is, here is my job satisfaction AV. Just select this. So this is my square root of AV for job satisfaction. And here family satisfaction square root of AVE. So I'm just using square root function. AV for family satisfaction is here. I just populated this here. Then this one is for work family balance, square root of AVE for work family balance here. Then square root of AVE for life satisfaction, that I'm keeping it here. Just keep it in bold font. So now if you look at, none of the interconstruct correlation is greater than the square root of AVE. So the discriminant validity of the model is well established. This is the way how you can present your results. Making sense? What happened? People are hungry. Since I gave 10 minutes break in the beginning, so I'm not giving anything here. So hardly I've got another 15 minutes time to wind up this. So any questions? Able to understand?
Yes, sir.
So once it is done, now the next job is doing the SEM analysis. How do you do it? So you go file. I'm just saving this diagram as SEM model in the same folder. Save it. And then I'm going to remove this correlations. I'm going to remove this correlations. Using the same diagram, I kind of trying to create the SEM diagram here. So now I'm just selecting the single letter arrow because I'm going to test my theoretical relationship, right? So I'm just drawing whatever may be the relationship I'm interested in testing. So all those relationships I'm keeping here. Then you select this pen tool. This is for touch up. You can do the touch up here so that it will be distributed uniformly. Up to this clear? Able to understand? So next what you do is you have to draw the residuals for your two endogenous construct. It's a mandatory thing. These terms are nothing but error term for the endogenous or residuals for the endogenous constructs. So now you go to plugins, name unobserved variables, E17, E18 will be placed on the errors or maybe residuals. So now I'm done with everything. So next job is click calculate estimate. Your SEM analysis is also done. Your SEM analysis is also over. Okay. How do we infer the result? You go to text output. First thing is you check the model fit. So chi-square divided by degrees of freedom is within the cutoff. It should be less than 3 or less than 2. This is fine. GFA is good. CFA is good. IFLA also good. Important for this RMSA, that value is also less than 0.080. So identically, I'm getting almost similar result in SEM also, something similar to my CFA results. So now the conclusion is, I'm getting proper fit to the data. So now I can infer the theoretical relationship which I have tested here. So how do you do it? You go to view text output. Okay. Click estimates. So here you get this coefficient table. So if you look at this coefficient table, I'm just copy pasting it in the Excel file. If you look at this coefficient table, these are all the unstandardized regression weights. These are all the unstandardized regression weights. So I don't need all of these values because these are all item level informations. Just remove it. If you need beta values here, you can also copy paste those beta values. From where you will get the beta values? So if you go to the text output, just below to this table, you have the standardized regression weights. So these values are nothing but your beta values. So you just simply copy this table, go to Excel, paste it here. You copy this first few rows of information, paste it in this beta column. Okay. Now you can get rid of this additional table. So now I have the beta values, B values, SC standard errors, see a t values, and then the corresponding p values. So now the result is, this is what your regression result table. So the result is job satisfaction to family, work family balance is positive, also significant. Family satisfaction to work family balance is positive, also the coefficient is significant. Work family balance to life satisfaction, the coefficient is positive, also it is significant at 0.05 level, not at the 0.01 level. Similarly, JS to life satisfaction, that is also significant because I'm getting 3 stars here. Then family satisfaction to life satisfaction, that is also significant here. Able to understand? This is how you can infer this result. So finally, you can say that whether the hypotheses are supported or not. Here I got good support. Everywhere I got the same result. So all the hypotheses are supported. Able to understand? So maybe you can come up with 5 different hypotheses. So this could be your H1, this could be your H2, this could be your H3, this could be your H4, this could be your H5. So all of the hypotheses are supported. So what I did here is something without any control variables. If you feel that gender is considered as one of the important control variable for work family balance as well as your life satisfaction, you just treat that particular variable as another independent variable for your model, another exogenous variable for your model. And as far as Amos analysis is concerned, you have to covary all of your exogenous constructs. You have to covary all of your exogenous constructs. So once it is done, now you just calculate estimate. So now you did the analysis after controlling gender in the model. So whether gender is related to life satisfaction, no, it is insignificant. Whether gender is related to work family balance, no, it is also insignificant. This is how you can control some of the demographics in the SIM model. If you have some construct as a control variable, that is latent construct means you just consider that construct as another exogenous construct in your theoretical model. That's it. That's the logic. That's the logic you have to use. Able to understand?
Yes, sir.
So this is how you have to do CFA and then SAB. So whatever the analysis, whatever the data I have used right now, same data-based explanation is available in my YouTube videos, in my YouTube videos, as well as the videos which I have shared yesterday. So once upon a time, we have developed a SWAM course. There I have demonstrated the same thing. So here also I'm doing the same thing. Clear?
Yes, sir.
Any questions? So now how do you infer the SEM results? Let me try to pick up one of my paper. See, this is typical SEM based paper. This is typical SEM based paper. It's one of the A level journal paper. So if you look at this particular paper, this is the model we have tested using SEM. This is the model we have tested using SEM. Okay. And the way how we wrote the result is as far as this paper is concerned, my contribution is doing the analysis, writing the data analysis and result section. That was my role as far as this paper is concerned. So we did CFA, and then we have performed a hypothesis, the 7-factor model, and then 5-factor, 6-factor, 4-factor, 3-factor, single-factor model. This is all nothing but CFA results to say something about the construct validity and reliability. Beyond that, nothing was discussed in this paper. Then we have presented our path coefficients in the same diagram itself, and then we just inserted this text box where we kept the fit values, chi-square value, degrees of freedom, GFA, CFA, RMCA. These are all the values I have reported here. And if you look at the hypothesis, for example, if you look at H5, we expect that mobile deal seeking will be positively related to mobile shopping intention. As expected, we found a significant positive effect between mobile deal seeking and mobile shopping intentions. Beta is 0.52, p-value is less than 0.001. This is how you have to report the results. And here we also inserted the R-square value. So where do you get the R-square value? To get the R-square value, you check the squared multiple correlations, and then you just run the analysis. You go to text output. So in the text output, if you go to estimates, scalars, squared multiple correlations. So here you will have the R-square values for your constructs. For work family balance, I'm getting 0.342 as a R-square value. For life satisfaction, I'm getting 0.743 as a R-square value. This is how you get the R-square values. Able to understand?
Yes, sir.
And I can show you one more reference of mine. Which paper I can select? This is one of my student paper, scholar paper. So if you look at this particular reference, here also we have used SEM. So this is the model we have tested. How performance pressure is related to innovative work behavior and task performance through problem-oriented daydreams. And if you look at the data analysis, here we did CFA and SEM. And if you look at the CFA results, this is how we have presented the CFA results. Then we have presented the convergent and discriminant validity results here. Then we have presented the marker variable CMB analysis results here. Then we have presented the same results here in the form of table. So B values, and then the significance, and then the R-square values, everything is presented here. And then in the result section, we wrote whether the expected relationships are significant or not. It's a mediation model. So here we have also tested and reported the mediation results. This is open access paper only. Anybody can refer this paper. I'll share this paper link also. Fine. In one more paper, so in this paper, what we did was, this is a model we have tested. There are 3 antecedents and 1 outcome and 1 mediator. And we just reported descriptive statistics table. And then we have reported the same results in the diagram itself. And then we also reported the factor loadings, Cronbach alpha, CR, AV values in a separate table. Then we also reported the indirect effect values, direct effect values. That's it. I'm sharing this paper result also. Yeah, any questions? Last 5 minutes.
Yes, sir.
Yeah.
There is a
sample size is less than 100, will this SEM analysis can be performed? Should it
You
reveal?
can do it, but you may not be able to get the appropriate fit values. First of all, I'm not sure whether model can be estimated also. Sometime it will produce error. If the model is not really complex in nature, I think you will be able to do it. If the model is really complex in nature, I think it's difficult. Making sense?
Yes, yes. Yes, sir. Thank you.
Clear?
So
Sir,
basically,
my question is okay.
Yeah,
sir,
please. Yeah.
sir, for a question of 31 questions, then what will be the correct exact sample size?
That's what I'm saying. No, 1:5 ratio or 1:10
That is
ratio you can follow.
150 required.
1:10 ratio is the ideal scenario. At least you follow 1:5 ratio. If your questionnaire is having 50 items means in total for the entire model, 50
31
into 5
items.
is the minimum sample you need to have. Sorry, Shamla.
31 items, then 31 into 5, that is 150 above should be, has to be.
Yes, that is minimum, bare minimum.
Minimum.
So 30 into 10 is the ideal scenario. So 300 samples.
300. Okay.
This is from the data analysis point of view. Sometimes people say that, no, he told me to have only 300 data to generalize my study finding. No, from the generalization point of view, you have to look at your study population. Are you getting my point? This is purely from the statistical analysis point of view.
Okay.
Clear?
Yes.
Yeah. Any other questions? Say 27, another 3 minutes. Yeah.
Just sir, I have two questions. One question is regarding the pilot analysis.
Yeah.
That is it necessary? Like we need to report it in the paper or not? Because sometimes reviewer asks that whether you did the pilot analysis and then pilot testing and then you go ahead with the final data analysis. So what is your view on that?
Come again.
It is about pilot testing before going for the final data collection.
See,
Because sometimes yes.
Yeah, as
Yes,
far
please.
as the pilot testing or pilot data is concerned, do you have enough sample in your hand in terms of running this sort of sophisticated analysis? If you don't have, whatever may be the results you are going to get, it's a erroneous thing. With the help of pilot data, maximum what you can do is you can check the reliability. Maybe you can do EFA. If CFA is done using any of the software, if the model results are coming, that's fine. If it is not coming, don't blame the technique, blame the sample.
Okay, sir. Okay.
Got my point?
Okay, sir. Sir, just one more question here. Like
Yeah,
sometimes it happens that participant has just ticked the questions. So
yeah,
at the end of the day, you just need to delete that data. Like you just need to see the how is the
yeah,
standard
yeah,
deviation.
yeah. See, there are different procedures are available as far as treating the missing values. So
Okay.
for if the missing values are really limited in nature, maybe you can also kind of replace the means. That is one way. Second way is you can also kind of, I mean, delete the entire row of the response that is coming from the particular respondent. That is also possible. So there are multiple methods are available in terms of handling the missing values. So for more details, you refer Handbook chapter number 2 or 3. So there they have discussed something about handling the missing values.
Okay, sir. Okay. Thank you so much.
Fine. Yeah. Any other questions?
So
Any
guys,
other
we are on the
questions?
verge of completion of this workshop, so it is important to kindly ask questions if it is possible.
Yeah. Any questions? So if there are no questions, I think we can wind up. Further in the near future, if at all you get some questions, you can reach out to me. This is my mobile number. And then my email ID is this one. So I just typed everything in the chat box. How to do factor reduction? See, factor reduction can be done using multiple logic, especially if you are trying to do a skill development study. So we try to sometime even remove the two highly correlated items also, because there you get into logic called conceptual redundancy or grammatical redundancy. Same items may be capturing the same domain. But in the factor analysis, whatever may be the item that is producing really poor loading, so those items need to be removed. And one by one, you have to remove it. You remove item, you run the analysis, and then you check the other items loadings. If one of the item is coming with the poor loading, you remove that. Again, you rerun the analysis. Especially in the scale development process, this is how we run the factor analysis. Clear? Making sense?
Yes, sir.
So if there are no more questions, thanks to IITG forum, I mean Career Development Forum, as well as Cyril sir for the given opportunity. And thanks to Ashutosh for coordinating this. And sorry from my side for the initial glitches, because in between completely I lost the internet connection. Then after 5 or 7 minutes, I could able to get the connection back. So I hope you got something. And one more disclaimer statement is, don't think that after attending this 3 hours, you will master everything related to SEM and you will be able to do everything by yourself. So SEM itself is a separate subject. So that much of content is available. So I used to deliver introduction to SEM for a whole day. I used to have some 150 slides, but here what I brought is not even 10% of those slide content. And I used to have separate workshop session for understanding reflective and formative constructs also. That much of content is available. But here I just give the simple overview to understand everything. So here my humble submission is, even if you don't know anything about SEM, even after attending this 3 session, you consider this 3 hour session as a eye-opening session for your future learning. And you go to my site under the structural equation modeling umbrella. I have given set of solid references. You go through those papers. You refer multivariate data analysis by handbook. You can also refer Introduction to Structural Equation Modeling using Amos by Barbara Bainey book. You will get good clarity. Clear?
Yes, sir.
Making sense?
So,
Yes,
sir, thank
yes, sir.
you.
Yeah.
So thank you from the whole student IIT Guwahati community that you have arranged a time from your busy schedule. And we also like to thank the CCT team who has collaborated with the Student Academic Board for this workshop. And I hope this workshop is really beneficial for our students. And we would like to have some more sessions of yours in SEM in future also.
Yeah, sure. Definitely. Yeah. Okay. Thank you. Good night. Bye
Thank
bye.
you.
Yeah.
Thank you
Bye
so
bye.
much, sir. Thank you for coming.
Thank you so much, sir. Thank you so
Thank you
much.
so much, sir. Good night.
Bye bye.
It's
Bye
wonderful conversation with you.
bye. Bye bye.
Yeah.